You're standing in a dense, humid forest. It's roughly 2 million years ago. The sun is high and your stomach is empty. There is no grocery store, there is no FDA, there is no internet forum to tell you if the bright red berry in front of you is a superfood or a neurotoxin. There is just you, a crushing biological requirement for calories, and a massive wall of green vegetation. And somewhere, at some point, one of your ancestors reached out, grabbed an unfamiliar leaf, root, or piece of fruit, and put it in their mouth. This is the story of how ancient humans knew what was safe to eat. And it was never really about luck. Here is a fundamental truth about the natural world that we have mostly engineered our way out of having to think about. Plants do not want to be eaten. We tend to look at forests and jungles as natural buffets, a peaceful backdrop of greenery just waiting to sustain us. But from a biological perspective, a forest is an active war zone. Animals have legs, wings, or fins. If a predator approaches, an animal can run. A plant cannot run. It is bolted to the ground. If something wants to eat it, it has to stand there and take it. Except, evolution doesn't let organisms survive for hundreds of millions of years without a defense mechanism. Because plants cannot fight physically, they fight chemically. For millions of years, plants have been engaged in an invisible, escalating arms race, developing some of the most sophisticated chemical weapons on the planet. They synthesize alkaloids, cyanides, tannins, and neurotoxins. They produce compounds designed to disrupt digestion, paralyze nervous systems, or stop a mammalian hurt completely. If you were to be dropped into a random jungle today, and you simply started eating the vegetation around you, grabbing leaves, snapping stems, eating whatever looked appetizing, you would not survive the week. Statistically, the vast majority of wild flora is either completely indigestible to the human stomach or actively poisonous. So the problem facing early hominins was severe. They were expanding into new environments. Every time they entered a new ecosystem, the menu changed completely. They couldn't just guess. A bad guess didn't mean a mild stomachache. A bad guess meant your nervous system shutting down in the middle of a grassland where predators were watching. The stakes of putting something in your mouth were absolute. If they were operating by blind trial and error, our lineage would have been poisoned out of existence before we ever figured out how to make a spear. They needed a system. They needed a way to decode the chemical warfare of the environment before it hit their bloodstream.
The first line of defense wasn't a cultural tradition or a piece of inherited wisdom. It was a piece of hardware. It was your tongue. We treat taste like an aesthetic experience. We think of our taste buds as tools for culinary enjoyment, something to help us appreciate the difference between a good steak and a bad one. But for the vast majority of human evolutionary history, taste was not about enjoyment. Taste was a highly calibrated biological hazard scanner. Think about the basic human flavor profiles: sweet, salty, sour, bitter, and umami. These are not random variables. They are incredibly specific evolutionary adaptations. When an ancient human bit into a piece of fruit and registered sweet, their brain wasn't just experiencing pleasure. Sweetness is the chemical signature of simple carbohydrates. It is the language of fast, safe, dense calories. The brain rewards sweetness with dopamine because, in the wild, sugar is rare, incredibly valuable, and almost never toxic. Nature rarely poisons the sugar.
Umami, that rich, savory flavor you get from cooked meat or mushrooms, is the chemical signature of amino acids and proteins. It tells the brain, this is building material for your muscles and your neurological network. Eat as much as you can. But then there is bitterness. Bitterness is the alarm bell. It is not an acquired taste. It is a primal warning. In the plant kingdom, the chemical compounds that are most commonly toxic to mammals, the alkaloids, the cyanides, the complex chemical defenses we talked about earlier, almost universally taste bitter to us. Humans have somewhere around 25 distinct bitter taste receptors, coded by a specific family of genes called the TAS2R family. We don't have 25 receptors for sweet. We don't have 25 receptors for salty. We have a massive, disproportionate neurological infrastructure dedicated entirely to detecting bitterness. And our sensitivity to it is astonishing. We can detect some bitter compounds at concentrations of a few parts per million.
When an early human put a leaf in their mouth and chewed, that scanner went to work. If it registered extreme bitterness, the brain didn't just suggest that maybe they shouldn't eat it. It triggered an involuntary physical rejection. The face scrunches, the tongue pushes outward, the saliva glands kick into overdrive to wash the compound out of the mouth, the gag reflex primes itself. This is why human babies inherently reject bitter vegetables. It is not because they are picky, it is because they possess the exact same untethered biological software as an ancient hominin. They are operating on a factory-setting survival instinct that says, if it is green and bitter, it is trying to kill you. Spit it out immediately. The tongue was the gatekeeper. It allowed our ancestors to interface with a new environment and rapidly sort the calorie-dense sugar from the alkaloid poison, all without having to actually digest any of it.
But the tongue wasn't perfect. Some toxins don't taste bitter. Some poisons hide behind sweetness or have no discernible taste at all. So what happens when the hardware scanner fails? There is a common myth about survival, one you see repeated in survival manuals and outdoor guides. The myth says that if you don't know what to eat in the wild, just watch the animals. See what the monkeys are eating. See what the birds are eating. If it's safe for them, it's safe for you. For an early human, following this logic would be a spectacularly fast way to die. A koala can eat eucalyptus leaves all day. If a human eats eucalyptus, the toxicity will destroy their liver. Vultures can eat rotting meat crawling with botulism. A human doing the same would be dead in hours. Many birds can eat bright red berries that contain cyanide compounds, completely unaffected because their digestive tracts are built differently or the seeds pass through them intact. Our ancestors figured out very quickly that you cannot outsource your dietary safety to another species. Evolution is highly specific. The digestive enzymes of a deer do not belong to you. So they had to rely on a different, much darker biological mechanism, the mechanism of conditioned taste aversion. Psychologists call it the Garcia Effect. Imagine an early human eats a new type of mushroom. It bypasses the bitter scanner. It tastes fine. They swallow it. 4 hours later, the toxins hit their bloodstream. They don't die, but they become violently ill. They vomit, they sweat, their body violently purges the contents of their stomach to expel the poison. What happens next is one of the most powerful learning mechanisms in the mammalian brain. If you touch a hot coal, you learn instantly not to touch it again. The pain and the action are simultaneous, but eating poison has a time delay. You eat it at noon, you get sick at sunset. For a normal brain, bridging a 4-hour gap between an action and a consequence is incredibly difficult. But the Garcia effect bypasses normal logic. If you get violently nauseous, your brain will automatically scan backward in time, identify the novel food you ate hours ago, and permanently wire the taste and smell of that food to the feeling of severe nausea. You don't have to consciously remember it. You don't have to remind yourself not to eat it. The next time that human even smelled that specific mushroom, their stomach would turn. The sight of it would induce physical revulsion. The brain essentially rewrites the software, creating a permanent biological red flag for that specific item. It is trial and error, but it is trial and error engineered for maximum retention. You only have to make the mistake once. The nausea becomes a biological memory. But individual memory is fragile. If every single human had to personally poison themselves just to figure out what not to eat, the mortality rate would be unsustainable. Surviving an evolutionary bottleneck requires more than just individuals learning not to eat the wrong berry. It requires a system to make sure nobody else eats the wrong berry either. This is where the human story violently diverges from the rest of the animal kingdom. Animals deal with toxic plants by avoidance. If a leaf is poisonous, the deer simply does not eat the leaf. They let the plant win. Our ancestors did not let the plant win. At some point, early humans looked at the massive, lethal chemical defenses of the natural world and decided to systematically dismantle them. They stopped relying entirely on their biology to filter out poison, and they started using technology. The first and most consequential piece of that technology was fire. We usually talk about the invention of fire as a way to stay warm, or a way to keep predators away in the dark. But fire's most profound impact was as a chemical processing plant. Cooking is, essentially, external digestion. Heat denatures proteins. It breaks down complex, indigestible carbohydrates, and crucially, it neutralizes a massive spectrum of naturally occurring toxins. There are countless roots and tubers in the wild that are mildly to severely toxic when raw, but entirely safe and packed with calories when roasted. The application of fire expanded the human menu exponentially. But fire was only the beginning. As human cognition expanded, so did our methods for overriding botanical warfare. Take the acorn. Oak trees produce acorns in massive, reliable quantities. They are incredibly dense in fats and carbohydrates, a perfect survival food. but oak trees protect acorns by loading them with tannins. If you eat raw acorns, the tannins will aggressively bind to the proteins in your digestive tract, causing severe cramps, malnutrition, and eventually kidney failure. An acorn is a rock of pure energy wrapped in a chemical lock. Ancient humans figured out how to pick the lock. They discovered that if you grind the acorns into a fine meal and then run cold water through that meal over and over again for days, the water will slowly strip the water-soluble tannins out of the flour. You are left with a perfectly safe, highly nutritious carbohydrate base.
Think about the cognitive leap required to achieve that. You have a food that tastes incredibly bitter and makes you sick. Instead of just walking away from it like any other animal would, you conceptualize a multi-day, multi-step mechanical and chemical process to wash the invisible poison out of the dust, transforming a toxin into bread. You see this exact same level of engineering with cassava, also known as manioc. Cassava is a staple root crop in tropical regions, but in its wild bitter form, it is packed with cyanogenic glycosides. If you eat it raw, your body converts those compounds into hydrogen cyanide. It is lethal. Yet ancient indigenous populations figured out a completely unintuitive process to eat it. They would peel the root, grate it, pack it into woven tubes, squeeze the toxic juice out of it, and then roast the remaining flour to vaporize the residual cyanide gas. How many people had to die before they perfected a 5-step process to extract cyanide from a potato? We will never know the exact number. But it proves that early humans weren't just foraging. They were running a brutal, generational science experiment to chemically hack their environment.
Sometimes, however, you couldn't process the poison out. Sometimes you had to eat the toxin anyway, because starvation was the only other option. When researchers study traditional diets, especially in areas with high concentrations of toxic flora, they frequently encounter a behavior that seems completely irrational to the modern mind: geophagy, the deliberate consumption of earth, specifically eating clay. For centuries, modern medicine viewed the eating of dirt as a psychological disorder or a desperate response to severe mineral deficiency. It was only when anthropologists started closely watching exactly how and when ancient and traditional cultures ate clay that the actual function became clear. They weren't eating dirt because they were starving. They were using it as a pharmaceutical shield.
Clays, particularly kaolin and smectite clays, have a specific molecular structure. They are negatively charged and porous. When ancient humans encountered a high-yield food source that was laced with toxic alkaloids, like certain wild potatoes in the Andes, or specific bitter acorns, they would dip the food in an aqueous clay slurry before eating it. When the food and the clay mixed in the stomach, the negatively charged clay molecules would act like a magnetic sponge. They would bind directly to the positively charged toxic alkaloids, trapping the poison inside the clay matrix. Because the human digestive system cannot break down clay, the toxins would remain locked inside the dirt and pass harmlessly through the gastrointestinal tract. They had effectively invented a broad-spectrum antacid and anti-poison pill. They were using the geology of the earth to neutralize the biology of the plants. It is a stunning display of environmental mastery, achieved hundreds of thousands of years before the invention of the microscope or the concept of chemistry.
The problem with our brilliant workarounds for survival, fire, leaching toxins from roots, using clay to neutralize poisons, is that they are dangerously complicated. They require highly specific, step-by-step instructions. If you miss a single step in processing cassava, you die of cyanide poisoning. Biology gave us some tools. It can pass down the bitter taste reflex through DNA, a built-in warning system. But DNA cannot pass down a recipe. It cannot tell your child to wash the acorn flour 6 times in a running stream to make it safe. To survive in a world surrounded by complex, invisible threats, early humans needed a new way to store and transmit data, something outside of their own genetic code. They needed a shared, external database to hold this life-or-death knowledge. They built that database using language, and they enforced its rules using one of our most powerful emotions: disgust. Language was the ultimate survival tool because it allowed a tribe to learn from a mistake without having to repeat it. If one person ate a toxic root and died, the rest of the group didn't just physically avoid the root. They named the root. They talked about the root. They wove the root into a story.
But humans didn't just rely on dry informational warnings. If you tell a toddler that a bright red berry is toxic, the toddler does not care. The toddler will wait until you look away and put the berry in their mouth anyway. To protect the group, humans evolved a psychological mechanism to make the avoidance permanent: the emotion of disgust. Disgust is a uniquely human phenomenon. Animals feel nausea, but they do not feel cultural disgust. Disgust is a psychological hack that takes an arbitrary rule and attaches it to your biological gag reflex.
Ancient tribes began creating food taboos. They didn't just say a certain animal liver or a certain plant was dangerous. They categorized it as unclean, forbidden, or spiritually contaminated. By encoding survival data into religious or cultural taboos, they ensured that the rules were followed with absolute rigidity. You didn't avoid the plant just because it might upset your stomach. You avoided it because eating it would exile you from the social fabric of the tribe. Over thousands of years, a tribe's culture essentially became a massive, highly encrypted survival manual. Every myth, every taboo, every traditional recipe, and every ritual was a line of code designed to keep the group from poisoning itself. The culture remembered what the individual could not.
Which brings us to the final failsafe. Imagine you are living 60,000 years ago. You know exactly which 40 plants in your territory are safe to eat. And then the climate shifts. A multi-year drought strikes the savanna. The primary food sources wither and die. The safe, reliable staple crops that your tribe has eaten for 3 generations are gone. You are now looking at a landscape of marginal, strange, and highly defended plants that you have never had to eat before. If you guess wrong now, you die. But if you don't eat, you also die. In this moment, the most valuable asset a tribe could possibly possess was not the strongest hunter. It was the oldest person in the group. Anthropologists have long debated the grandmother hypothesis, the question of why humans, almost uniquely among mammals, routinely live decades past their reproductive prime. So why do human females experience menopause and then live for another 30 or 40 years?
The answer is data storage. In a pre-literate society, an elder is not just a grandparent, they are a living library. A 70-year-old woman in an ancient hunter-gatherer tribe has survived environmental cycles that the 20-year-old hunters have never seen. She remembers the great drought from 50 years ago. She remembers which bitter berry tubers kept the tribe alive when the animals disappeared. She remembers the multi-day boiling sequence required to remove the toxins from those famine foods. When the normal rules collapsed, the elders were the emergency backup system. They held the deep-time database of the environment. The tribe kept them alive, shared scarce calories with them, and protected them, because when the world changed, the memories inside the elder's head were the only thing standing between the group and extinction. They didn't have the internet. They had a grandmother, and her memory of what a safe leaf looked like in a dying forest was the ultimate difference between life and death.
We treat food today as an issue of preference. We walk down the aisles of a brilliantly lit supermarket, entirely insulated from the green war raging outside. We pick up a bag of almonds, a sack of kidney beans, a bag of potatoes. We complain about the price. We worry about the carbohydrates. We do not think about the fact that raw kidney beans contain a toxic protein called phytohemagglutinin that will cause severe internal bleeding if you don't boil them properly. We do not think about the fact that wild almonds are loaded with cyanide, and it took centuries of selective breeding to mutate them into something that wouldn't kill us. We do not think about the solanine in potatoes or the phytic acid in grains.
The grocery store feels like a given. It feels like a natural state of peace between humans and the earth. But that peace is an illusion. Every single safe calorie in your kitchen is the result of a 2 million-year-long high-stakes war of attrition. You can eat safely today because thousands of unknown ancestors paid the ultimate price to draw the map. Because someone figured out how to wash the poison from the root. Because someone figured out how to trap the alkaloid in the clay. Because a grandmother remembered the famine and a tribe turned a lethal error into a sacred story. The next time you sit down to a meal, look at the plate. There is no such thing as a simple piece of food. There is only a monument to the people who figured out how to survive a world that wanted to kill them. And they did it all without ever reading the label.